This LOS is calculate and interpret the effective annual rate given the stated annual interest rate and the frequency of compounding. Okay, the nominal interest rate is the basic rate that is charged or earned for any compounding period. And the effective annual interest rate is based on the number of compounding periods. So in the example that we're going to look here below, we're going to look at investing $100 in a bond that pays 6%, that's the nominal interest rate, but it's compounded twice per year. So we have to figure out what the effective rate is. Okay, so we have an algebraic formula here at the top, and don't be intimidated by it, because the logic, it's very easy to answer these questions not using algebra. But in this case, the effective annual rate is 1 plus the interest rate, nominal interest rate, divided by M. So in this case, M equals the number of compounding periods, okay? So if we're compounding semi-annually, M would equal 2. If we're compounding quarterly, M would equal 4. If we're compounding monthly, M would equal 12. If we were compounding daily, M would equal 365, okay? So M is the number, the frequency of compounding. And N in this case is the number of years. And in this little example, N is 1 because we're just doing 1 year. So we're investing in a bond that pays 6% compounded twice per year. So the interest rate per period is the 6% divided by 2 equals 3%. So as I said, an easy way to do that without the algebra to figure out what the effective rate is just some common sense. I would start it with $100 times 1.03. So at the end of 6 months, I would have $103, and then times 1.03 for the second part of the year, and I'd have $106.09 at the end of the year. So we know anyone can calculate ending minus beginning divided by beginning. It's going to give us 6.09%. Okay. So again, just to show you the interest that I earned in the first half of the year, $3, 100 times 3%. And then it's compounding, interest on interest. So I had $103 at the beginning of the second half times 3%. I would have earned $3.09 in the second half. So my total interest was $6.09. And so I had a nominal interest rate of 6%, but because it's compounding semi-annually, I've got an effective annual interest rate of 6.09%. Okay, this slide is just writing out the algebra here for you in more detail. We did it fairly quickly on the previous slide. So there's the formula. And so we're doing 6% compounding twice a year, semi-annual. So we can see how do we calculate the effective annual rate? 1 plus the 6% divided by 2. So the keystrokes is 0.06 divided by 2 plus 1, y to the x2. That's the compounding number of periods per year, and n, it's for 1 year. So y to the x2 minus 1 times 100, and you'll get 6.09%. So let's just do that again. 0.06 divided by 2 plus 1, y to the x2 minus 1, and times 100 if we want, and it's going to give us 6.09%. Okay, there's an easier way of doing it using the calculator, and there's an interest rate conversion here above the to key. So to access, anytime you see a functionality above a key, you have to use the second button and then hit that key. So we have interest rate conversion above the second key. So to do this one again, I'm going to show you how to do it. We're going to do second interest rate conversion. Oh, sorry, didn't press the second hard enough. Second interest rate conversion. Our nominal interest was the 6%, so we just hit 6, and then we hit enter. And then we arrow up, and the compounding periods per year, it's already set at 2. Okay, that's in there from a previous example. If it was quarterly, I'd press 4. If it was monthly, I'd press 12. So it's set at 2, so that's fine. Just 2, enter. Arrow up, and it's giving me the effective yield, showing 0, 0, because the calculator had been cleaned. I'm going to just hit CPT, always hit compute. So I hit compute, and bam, it gives us the effective rate is 6.09%. So a lot easier than using the algebra. Use our interest rate conversion key. Second, interest rate conversion. type in the nominal rate, arrow up. Don't worry if you arrow down. If you arrow down, you can arrow down or arrow up. It doesn't really matter, suit yourself. But we always start by putting in the nominal rate, then the compounding periods per year, and then finally when we hit the get to the effective key, we hit compute. So here's a quick practice question for you. If the stated annual interest rate is 20% and the frequency of compounding is monthly, the effective annual rate is closest to A, 20%, B, 21%, or C, 22%. Well, we know it's going to be higher than 20% because we're compounding more frequently. So A doesn't look right. So it must be B or C. Okay, the correct answer is C. So we could do this using the algebra, or we can do it using the calculator, and I'll show you both ways. So remember, to calculate the effective rate, it would be 1 plus 0.20, it's 20%, divided by 12, and then to the mn, so it's 12 because it's monthly, times the n because it's just for 1 year. So let's just do it on the calculator. That would be 0.2 divided by 12 plus 1, y to the x, 12, minus 1 times 100, and I get 21.939. So it says closest to. You have to be careful sometimes that when they say closest to, they're not giving you the exact number. So you look very closely. 21.939. Sometimes I'm going to write it down just because even when you're looking left to right from your calculator down to the page, better safe than sorry, 21.939, that's closest to C. Okay? Now the easier way to do it on the calculator using our interest rate conversion, we do second interest rate conversion. Nominal interest rate is 20. So we hit enter, arrow up, compounding periods per year is 12. So we hit enter, arrow up, and we hit compute for the effective rate, 21.93911. So it's giving us almost the same answer from the calculator, 21.93911, because I'm using 5 decimals on the calculator. So the answer is C. Some folks love the algebra, but I think it's easier to use the interest rate conversion functionality on the calculator. Here's an interesting little problem. It requires you to do a few calculations in one question, and that's quite common with the CFA. The nominal quoted annual interest rate on an automobile is 10%. The effective annual rate of the loan is 10.47%. So the frequency of compounding periods per year for the loan is closest to A, weekly, B, monthly, or C, quarterly. Okay, the correct answer is B. And here we have the algebra. I'm not going to run through it, but you can see the first one was weekly, so our frequency of compounding is 52 weeks. The second one is monthly, frequency compounding 12 months. And then finally, quarterly is 4. So you can see here 52, 12, and 4. We run the algebra. But this question is a lot quicker. Speed is a skill. Skill gets rewarded. 90 seconds per question on the CFA. It's a lot easier to use the calculator. So let me show you how to do that. Again, it's the interest rate conversion. Second, interest rate conversion. Nominal interest rate is 10. We hit enter. So for the first one, it's weekly. So that's 52. Hit 52. Enter. Arrow up. Hit compute. And that's 10.50. So that doesn't seem right, but I'm going to write that down. 10.50648. Okay? So now, as I said, it's really easy if you use the calculator because you can just arrow back down and your compounding periods per year, just change that to 12, hit enter, arrow back up, hit compute again. Oh, 10.47131. 10.47131. Yeah, that looks like I'm right, so it's B. Okay? And if I just wanted to check, better safe than sorry, just go down and hit 4, enter for my compounding periods per year, arrow up, hit compute. No, it's 10.38 on the quarterly, 10.38129. So you can see these numbers match up with a bit of rounding doing the algebra. But I could solve that B a lot quicker than 90 seconds, come up to the right answer that it's B. Thank you.